Okay, so I would say that we mastered it in an excellent way. Let me do a short intro. Welcome to our second webinar. I mean, I suppose that the first one was extremely interesting, at least for me, to frame the subjects of AI, of trustworthy AI, of future developments. Now we are doing part 2 to give also other projects of the cognitive computing and cognitive cloud clusters the chance to share. And the discussion will be very interesting and also complement the previous one. Now wait, because I need to move my slide. Okay, just a quick overview. This is our agenda. Fred, the technical coordinator of ACES, will give a brief intro. Albert will tell us a bit about the EUCI coordination and support actions and how they coordinate all the projects and act as a hub. And then we have 4 sessions. One introductory session where all the projects of the clusters will present themselves. The sequence is the one indicated. In session 2, we will discuss the issue of training. How do we use AI effectively for the purposes of cognitive-enabled computing and cloud? In session 3, we discuss a little bit about the future. We try to look into the future. Then we will have a brief break. In that, we will have a presentation of 2 projects which are relevant to this topic and demonstrate concrete applications of cognitive cloud and to this area. And in session 4, there will be conclusions will be drawn. That's about it. Just the housekeeping. Please make pauses. We are recording the meeting. Make pauses because to make meaningful segments of the overall recording and enable people to focus on the parts they're interested in. Please make pauses. So breathe and make a few seconds pause, because this will enable us to make cuts in the videos and clearly distinguish the parts one from the other. So that's it. I wish you a productive session and buon lavoro.
Thank you very much, Luca. The sessions, like Luca mentioned, will be 40 minutes, 20 minutes, 20 minutes. In the 40-minute session, each project will get the opportunity to present what types of AI they're using in their framework and what is it used for. After that, we'll have kind of a roundtable discussion, more session 2, where we talk about the AI needs to be trained and deployed and managed efficiently. And session 3 is where we look at the future. Albert from Martel will tell us a little bit more about the bigger context within which this seminar is taking place. Albert, over to you.
Thank you, Fred. I will share my screen briefly for a short deck of slides. Does this work? It doesn't work the way I expect it to work. Can you see my screen at all?
Yeah, absolutely.
Okay, perfect.
No
Thank
problem.
you. Then I will put it in presentation mode. Sorry for the delay. So yeah, thank you, Fred. My name is Albert. I represent the Open Continuum CSA as part of the EUCloudEdgeIoT initiative, which is consisting basically of 2 collaborating CSAs. So Open Continuum, we focus on the supply side of the spectrum, where we have more focus on the establishing the connection to the industrial open ecosystems. But we also work on open source and open standard connections to make sure. So recently we had a long session in Helsinki with IEEE, IC41, where we discussed some of the projects that we're working on, and they were presented on stage. as well as the reference architecture and taxonomy that's created with all participants in the community. Open Continuum will finish by end of August, and we will hand over to Nexus Forum. So there's a continuation in this collaboration between two CSAs. Unlock is focusing more on the demand side. They did some investigation, they work with the industries, but they have a bit more focus on the MadeOSs than on the other projects in the community. Nevertheless, the work they do is very, very interesting to make sure that you as a project or as a group of projects have access to the industry stakeholders if you would like to. The joint CSA work in joint task forces. There are 6, 4 of them are led by Open Continuum. One is dedicated to these liaisons, interacting with the EC, make sure that we have good connection to AIoTi, Gaia-X, all these initiatives that help us and should support us on the standards and the way we should deliver our outcomes to the European Commission. There's Eclipse as one of the many open source foundations that we can work with, but they take the lead. So they introduce Linux, spyware, and there's some European smaller size open source groups that we work with. They do a lot of presentation and positioning of the open source solution, so they can help you position your results in the open source spectrum if you wish to. Eviden, former Atos, is focusing on the taxonomy and the reference architecture. A long list of working groups have been working on it very intensively, and the first results are now on the website. There's going to be a small update, I guess, after some debates, but it's nearly finished. Unlock, sorry, I think I'm switching slides. I wouldn't intentionally. IDC and BlueSpecs are leading the workshops, and we are working this task forces mainly on the open calls, understand how the market take-up is from the work that we do in the community. And IDC is doing a lot of studies and providing the markets inside, but also sector-specific needs as defined. And then there's the Task Force 6, which is hosting us today. It's the jointly led Open Continuum and Unlock, Martel, and Trust IT. So having said that is what we work on. The community has started with just 6 to 10 projects, and we grow this in 2 years to more than 50 members. All these projects are connected. So if you need access to one of them, reach out to Katarina or Maria in Task Force 6. They can lay the connection. You can find all the details on the website. But this is what we want to do as a community, make sure that we lay the connections and we can benefit from this. Today, we have the last of the RIAs Showcase webinars. This is the second version of the cognitive cloud computing. And I'm looking forward to have this participate in the discussion and listen to the discussion on AI, because that's one of the things that we will discuss also very much in the final event that we are planning. And it's happening on June 18th. All the projects that have not yet registered and would like to participate, please look in our website of EUCloudEdgeIoT.eu, register for it. It's a panel-driven event, so no long presentations, but it's interactive. It should be real good to have the discussion with the EC and the industry panels. There is already 6 of the projects that have registered. But if there's more, we will have 2 panels on cognitive cloud, cognitive computing. And with Fred, I will have some connections later this week, maybe today, to see how we can spice this specific panels on cognitive computing. So if you register, I will invite you to be on a panel as much as possible to make sure that we have a discussion, not just on the cloud parts of the cognitive side, but also on the specific topic of AI. Because we will have in the afternoon an industry reflection panel that will give some feedback on the discussions from the different panels. So panels on cloud, panels on MadeOS, open source, next generation IoT and Swarm, to see how they will embrace the potential outcome and results from this research and development of the project. This industry panel is slowly getting together. You can imagine not every person that we address is willing to travel for 30 minutes, we want to make it in person to meet, so you can meet all these people. But if you have an interesting person that you think should be on the panel for the industry, so not from the project, but from an industry, please suggest so we can invite him or her to join us. We have dedicated cloud providers, we have software-defined vehicle, and we have SNS network services. We're looking for health, because cloud in health is taking up heavily, and here's AI very important. So help me, if you can, register for the event, take part in the panels, and suggest people that we should have in the industry panel if you can. This is my introduction, and let's have a great webinar here today. Thank you.
Thank you very much, Albert. Let's go over to session 1, where we go through the various projects and try to answer the question, what types of AI are you using in your project, and what are they used for? The first project that is going to present, I think it's the DeCise project. Sabri Pilana is going to present. Am I correct?
Yes.
And who is running the slide show? There we go. Chiara is running the slides. Thank you, Chiara.
Thank you. You're welcome.
Sabri, go ahead.
Okay, what I see is the last slide of this size. So if you could move forward to the first one. Okay, that's great. Okay, thank you. Yes, so I'm going to give a very short overview presentation of European Union funded project DeCise. And as I think most of the projects in this group of projects, we are also trying to make the use of computing continuum from high-performance computing resources, cloud resources, up to the edge and IoT devices easier, using also artificial intelligence. So if you could move to the next slide, I could say just a few words about me. So I'm since 2.5 years at Forschung Burgenland, where I lead a center of smart computing continuum. Before I worked for 8 years as associate professor in Sweden. And before I moved to Sweden, I spent 12 years at the old University of Vienna. So I'm senior IEEE member. I work as an expert evaluator for various European Union projects in this domain. I coordinated a paper project. It was a European Union FP7 more than 10 years ago. And I'm a HighPeak member since 2010. So if you could move to the next slide, I could just say something about the DeCise project. So it's a 3-year project that started in December 2022, and it has like 4 main objectives. So we are aiming to develop a management framework for computing continuum. There will be some tools developed that will make this framework, let's say, possible, that would enable it. And then there are 2 key, let's say, building blocks. So we have a digital twin of continuum, and we have something that we call AI-enabled optimization. So we have 13 partners from 6 European countries, and the project is coordinated by Göttingen University from Germany. So maybe we can move to the next slide. And so what we see here, it's a high-level architecture of DeCise. And this blue light box this is what we intend to develop during the project, and partially are already developed. And we can see that the DeCise framework has 2 key components. So there is this digital twin of computing continuum that monitors the whole system, and hopefully it will also be possible to answer what-if questions, at least in short term. And this digital twin then interacts with the scheduling process. And for scheduling, we have several, let's say, efforts. So 2 major efforts are something that we call AI scheduler, that is based on artificial neural network. As far as I know, my colleagues in Germany are working on currently using recurrent neural networks, RNN, how they are known. And we have a group that is working in integer linear programming, ILP, so that it's also trying to optimally map resources to the workload. What we see here down with purple boxes, these are mainly existing components that have been developed in previous, let's say, projects. And one of these key components is something that is called CubeEdge, that it's a group of organization behind it. So it's a whole consortium that basically it's a Kubernetes extended for both, let's say, cloud and edge computing resources. So we can move maybe to the next slide now and talk a bit about use cases. As most of the project in this cluster, we have also 3 use cases that we use for inspiration and demonstration during the project. So one is something that we call intelligent intersection. And it's basically it's focused on automatic detection of vulnerable traffic participants, like, I don't know, pedestrians that may be hidden, maybe somewhere around the corner, and the driver cannot maybe see in the time. But in this scenario, then this would be detected by cameras that are at the intersection, and maybe the car would be able to communicate with infrastructure and get a real-time warning that behind the corner is something that the driver should pay attention to. Then there is a classic healthcare application that it's basically MRI scans that combines, let's say, resources that are close to the MRI device with resources at some high-performance computing center to provide as soon as possible results to the medical, let's say, personnel. The third use case, it's basically using drones in the context of emergency response. And again, we have in this use case a typical scenario where we have drones as basically edge devices that communicate with a near, let's say, computing infrastructure, but also large-scale computing resources at some, let's say, high-performance computing center are used. So what we see in this slide, and there are a lot of components that the project intends to use, or at least to give a chance to test them during the project to make this possible. So from this hardware infrastructure at the bottom, then there are a lot of layers in between, let's say, from file system, operating system, middleware, and various schedulers. Okay, so this is all about this side. So I thank you for your attention, and probably we will have a chance also to answer questions if there are any about the project later on. Thank you.
Thank you very much, Sabri. Just a quick question to your project. So if I understand correctly, you use AI in the orchestration. That's the place where you use AI, no other place in the architecture. Am I right?
Yes. So we use AI for scheduling, what we call.
Oh, scheduling.
Basically,
Yeah, okay.
mapping workload to resources.
Yeah.
But there is always a but. So there is hidden use of AI within use cases. Of course.
Yeah, of course.
So for traffic intersection, object detection is, for example, you need AI.
Yeah.
And also the drones, for emergency response, they need to use AI. But that's not the aim of project to advance the state of the art on object detection.
Yep, fully understand. Thank you very much, Sabri. Let's go on to the next project, Empyrean. Panos or Panagiotis Kokinos will present that one.
Yes, hi all. First of all, I'm sorry for some noise or some disconnection because I'm traveling to a conference. So sorry for any bad quality. So let's start. And this is the reason I won't open the camera. So hi all, my name is Panagiotis Kokinos. I'm from the Empyrean project. The full name is Trustworthy Cognitive and AI-Driven Collaborative Associations of IoT Devices and Edge Resources for Data Processing. It is a research innovation action. It started in February. We have 11 partners from computing, cloud computing, edge computing, companies in various domain areas, experts in computing and storage. Next slide. So the idea of Empyrean is to build what we call associations. It is collaborative. We say that's collaborative collectives of IoT devices, robots, edge and cloud resources. So the idea is that each association operates autonomously, organize the resources, organize the devices, and shares the devices and the resources between the participant users. Each association has a secure and trusted environment. So anyone that participates in this environment, in this collective, it can trust the resources, it can use the resources in a trusted manner, so it's secure. Each association has an edge storage service, and also there are other services for decentralized communication, utilizing various communication media, for and also supporting AI-driven application development and deployment. So in the figure, what we see is this set of associations. So each association is IoT devices, robots, resources, and the management control plane in each association. And all of these are interconnected through what we call an Empyrean registry that helps interconnect them when and if needed to exchange data or to move migrations from one association to the other. Next slide, please. We have 3 use cases. It's 3 plus 1. So the plus 1 it is a South Korea-based use case that it's about smart factories that we are on discussions of how to implement. So the three main use cases are all about have something to do with robots. So we have an advanced manufacturing use case where we have robotic components that help in the manufacturing process. We have a smart agriculture use case where we have again robots that operate in the field and drones that again operates in the fields. And we have a warehouse automation use case where we have small robots that move inside the warehouse and move objects in the various fields. The idea here, of course, is to use these associations, the idea of the associations and the developed components so as to serve the respective workflows, to serve AI ML-based workflows in these different use cases. Next slide, please. So here we illustrate the life cycle we envisage in this project. A workflow-based provides a description indicating which COD devices, which robots will be invoked, and which kind of processing or storage we need. And then the Empyrean aggregator receives this workflow, decomposes appropriately, and then based on AI mechanism, assigns the workload to the various resources, either inside the single association or utilizing multiple associations. And of course, we have various other mechanisms for service assurance, for security and trust management that support the operation of an association. Next slide, please. Okay, here we see some of the components of the aggregator that will be composed the control plane of an association. So it has various components for decision making, for storage, for data distribution, for telemetry, for cybersecurity threat identification, for analytics, and of course an SDK to support the development of applications. Next slide, please. So what we just ask the impact of the Empyrean is to
No, the connection is quite bad. We can't hear you at the moment. Could you move to a location?
It's continuum, so it's. Can you hear me now?
Well, I can hear you now saying I can hear you now, but the rest we don't hear much about.
Sorry.
So if you could explain this slide one more time. Okay. Okay, I think. Sorry, but then we need to finalize this presentation.
Yes. Okay.
Sorry,
No problem.
Paulus. Yeah.
No problem. I am sorry. Thank you.
I have a few more questions, but I will ask those questions later if there's a better connection. Yeah. Thank you very much for your presentation. Let's move on to the next one. Hyper AI. Lakonos Michailidis, if I pronounce that correctly. Probably not.
No, but anyway. So my name is Iakovos Michailidis. Hi, I'm the project coordinator. Iakovos, it's not an L. Yeah. I know it looks like an L, but it's not. I'm the project coordinator of Hyper AI. So thank you for hosting the webinar as well. So Hyper AI. If you can move to the next slide, please. So Hyper AI is a research and innovation actions project. Here are some generic, let's say, statistics for the project. It's a 36-month duration, 15 partners in total, 12 European ones, 2 Swiss, and 1 actually international from South Korea. This is our consortium. It started in 1st of April, 2024. Yeah, that's it. You can move to the next slide, please. So about the key objectives. Which also reflect the layers of our architecture, and also which we'll explain later, and also reflect the work structure as well. So the first key objective is about the Hyper AI architecture to allow the collective intelligence. This architecture will be, of course, considered and aligned with existing standards. For open architectures. The second objective is to ensure autonomous smart nodes and rapid coordination of smart nodes during application runtime. So we consider autonomous, let's say, nodes of cloud continuum resources that self-organize and react in a synergetic manner to host an application. The third key objective is about security and privacy across the cloud continuum. The fourth one is about promoting open nature of Hyper AI across different, let's say, outcomes and results of the project, both AI results, architectures, whatever is the outcome. And the fifth one is the demonstrations of the Hyper AI, which we envision to have 5 industrial use cases into quite, let's say, intensive big data applications. The next slide, please. So, in a nutshell, Hyper AI is about enabling the efficient execution of intensive data processing applications managed in a hyper-distributed manner by opportunistic autonomous smart nodes, in a nutshell. Okay. Next slide, please. This is the architecture that I mentioned before, which aligns to the key objectives as well. You can see the different layers. I will explain in the next slide, please. So the very first, let's say, layer is the abstraction layer. So resources abstraction and functional registration. Here we develop mechanisms about resources discovery and abstraction. Abstraction meaning here that we are going to use semantic web abstractions and representations to allow seamless querying of this kind of resources, cloud continuum resources, of course, in order to be able to manage them at runtime. Next slide, please. The second layer is about developing AIs that will orchestrate and configure the network resources. So we envision to build AIs for a full state estimation of the cloud continuum, first of all. So based on this situation awareness, we are going to also filter any erroneous data or heal any erroneous data from the field in a distributed manner as well. Moving the flow upstream, we are going to develop tools that are going to let's say create and manage the life cycle of different nodes, of different smart nodes in the cloud continuum. And as the last layer, we are going to develop train policies for self-configuration of these smart nodes, internal configuration, so offloading, scheduling, and stuff like that, to get access to the iron, as we say. So going down to the to assigning, let's say, tasks to different available resources and devices. Next slide, please. Yeah, we are also going to develop a distributed AI tools for intrusion detection as well, to ensure security in a more distributed manner, again, using also DLTs, distributed ledger technologies, for identity management and encryption as well. This is the last layer, which glues everything, all communications and all transactions together. Next slide, please. Finally, we are going to have, for the application definition, the big data intensive, the data intensive application definition layer, we're going to develop an IDE for end users to be able to define these applications and their, of course, constraints and requirements accordingly. That will be also using semantic web representations to represent the application needs that we will have eventually to balance between the availability of resources and the application needs at the end. This is the entire, let's say, technical structure of the project. Now going to the use cases, we have 5 use cases. Let's go to the next slide. The first one is under Industry 4. These are also AI applications, but we don't focus here on these AI applications because these come from the application provider, right? So these are given, let's say, for the project, and these will be managed by the resources, the available resources. So this application considers AR solutions for remote support and maintenance of manufacturing lines. In specific, we are going to run tests. We envision to run tests for the installation of middle voltage and low voltage substations in the industrial automation systems. This is the first, let's say, use case. The second one is, next slide, please. The second one is simulation of radioactive pollutants dispersion and safety. Let's say measure to create safety measures for nuclear reactors. This is an energy, let's say, related application. Next slide. The third one is about collective mapping and situation awareness from different connected automated vehicles, CCAMs, to increase the perception, the real-time perception on the road in a collective manner. So different cars will be providing infrastructure to run this application at the same time. The fourth use case is Agriculture 4. It's about optimizing the use of resources like water, like irrigation, like fertilizers, nutrients in remote agricultural areas. So cloud here will be quite difficult to reach. So it's purely at the edge, this use case. And the last one is provided actually by the international partner, the South Korean partner here, is about fusing data and simulating pandemic risks, assessment of pandemic, let's say, risks from originating from plants or animals, using data and databases coming from their side, using deep learning applications and mRNA, let's say, data. And I think next slide, please. Yeah, I think this is it.
Thank you, Jakobos. But we took a little bit more time, but I have still one question
Sorry
for
for
you.
that. Yeah.
No, it's okay. The semantics, what kind of framework are you using to kind of map the semantics or collect them and create them?
Well, the idea is to use existing standards like SAREF to look into, at least SAREF and ETSI standards on that. I think we have spotted one that is already public under the 3WC, let's say, website. Yeah, we are looking into that. This is an undergoing, let's say, task for as we speak. So
yeah,
we have
a complex task as well. So
it's a complex task. The idea here is, I mean, to use existing ontologies and prune them, actually, not create a new one from scratch, because this is a project itself. So we don't have the resources.
Okay, good. Thank you very much.
Oh, you're welcome.
Let's move on. Let's move on to the next project, ML SysOps. Christos Antonopoulos, would you please present your project?
Yes, thank you. So I am representing ML SysOps. I am a professor at the University of Thessaly, which coordinates the project. So again, it is a RIA project. We kicked off in January 2023. So we are a bit before the half of the project. The project, the consortium consists of 12 partners from 8 countries, and the partners range from large enterprises, SMEs, research centers, and universities. Let's move to the next slide, please. So what problem are we trying to solve? Applications tend to move outside the cloud towards the edge. So this involves different types of nodes, ranging from very powerful ones to very low power ones, different types of networks, and so on. So the scale, the heterogeneity, and the volatility or dynamics of the systems increases, and this increases a lot management complexity of those systems, and this makes such systems practically impossible to be managed by humans. So the vision of autonomic computing systems that appeared a couple of decades ago is again very relevant. What we inspire to do as a project, and we can skip the next slide and move to slide 4. Please, we can skip this one. So what we're trying to do as a project is to enable autonomic systems at the continuum using ML and AI as an enabler. So what we are going to do, what we are doing, we are developing an agent-based framework to manage continuum systems. We couple this framework with an AI architecture that supports explainable and efficiently trainable ML models to manage the system. Given the heterogeneity of the system, we also provide mechanisms that allow efficient, flexible, and isolated execution across the different and very heterogeneous nodes. Our optimization target is resource efficiency across the system, robust system operation, and the utilization of green energy wherever available, while at the same time, of course, satisfying the quality of service of applications. And we want to provide realistic solutions in the area of model training, validation, and evaluation. Let's move to the next one. So this is the general concept of the system. Starting from the bottom, we have, as I said, different types of hardware. ranging from cloud infrastructure on the right to very lightweight devices that cannot even run an operating system on the left, on the far edge. And in between, we have somewhat powerful edge infrastructure or smart nodes that have computational capabilities at the smart edge. On top of those systems, there are typically already existing management mechanisms and mechanisms for resource provisioning, for deployment, for orchestration. And those mechanisms cover different concerns such as computing, storage, and networking. Now, going to the top, we have applications. We focus on applications that are distributed and consist of several components, interconnected, communicating components. We have application owners provide their descriptions, their intents, and their requirements. And we also have infrastructure providers that provide descriptions of their infrastructure and the intents, so what they are trying to optimize. And the MLSysOps framework sits in between. So we take those requirements on top and we try to analyze and plan in order to provide concrete commands to be executed by the management plane. So the concerns we focus on are computing, storage, networking, both at the far edge, so for example, 5G, down to the optical networking in data centers. We focus on trust and security, and we also provide, as I said earlier, enabling technology for flexible deployment of applications. And then, in order to be adaptive, one has to monitor the operation of the system and provide feedback. So essentially, up to now, this is a conventional MAPE loop. The magic sauce here is the fact that decisions are made by AI. So we have AI models that are that focus on continual learning, so they can evolve, they can improve their decisions, they can react to changes in the system. They are hopefully explainable. Okay, so we can understand their decisions and attribute behavior of the system to their decisions. And another key property is that we want those models to be pluggable. So we want third parties to be able to contribute such models to the system. We can move to the next slide. Now, this is a very complex system, and in our opinion, the only way to manage that is to organize a hierarchy. So we have agents that are organized as a hierarchy. We start at the continuum level. We go down to the cluster level. So the cluster is a collection of compute devices that are closely together. And we go down to the node level, to the management of each individual node. So there are agents at each level that communicate with the other levels. Those agents provide commands to the orchestrators or even to the hardware at each respective level. And of course, in part with the agent hierarchy, there is a telemetry hierarchy that collects information and modifies information at the correct granularity for each level. So, for example, at the node level, we collect very low-level metrics. However, those metrics are combined to more high-level metrics as we go to the cluster level or to the continuum level. Let's move to the next slide, please. So for the ML architecture, we use reinforcement learning as the basic, let's say, technique. But as I said, we have a hierarchy of ML agents, different ML agents for different levels of the hierarchy, treating different concerns, and also different ML models for different resources and different parts of the system. So, for example, for computation, for storage, for networking, and so on. Let's move to the next one. We have in the consortium 2 real-world application use cases. One is focused on smart cities. So we have an existing system that offers both cloud capabilities and edge capabilities on smart lampposts. And we want to make the system be able to react to events on the road and reorganize resources to use resources wherever they are required. The second use case is smart agriculture. So we have a company that provides a system that visually identifies in real time the requirements of the field and applies herbicides or nitrogen according to the needs of the field. And what we do is we extend this platform with a drone because sometimes you need a better perspective if, for example, the sun is very low and so on. So we have already developed an autonomic drone that cooperates with the tractor to optimize herbicide operations. And this actually is a photo from one of the tests we have run. Let's move to the next one. So what we have done so far, beyond requirements collection and the design of the architecture, we already have the first implementations of mechanisms, ML models, and agents. We have established the 2 real-world test beds. However, at the same time, one of the key problems to use ML is to be able to create data at scale. So beyond the real-world test beds, we also have 5 simulation environments and 5 research test beds. Next one. And so what you can expect from us, we are submitting a proposal to organize a workshop with other projects of the cluster in HighPeak 2025. In late 2025, we also plan to organize a hackathon to allow developers to play with the MLSysOps infrastructure. And we will gradually release components of the framework as open source to the public. So thank you.
Thank you, Christos. Please, the invitation, send it also to the participants in this webinar, because I think they will all be interested. I have one quick question. Infrastructure as code, what kind of framework are you using there?
Yeah, we have currently defined our own semantics, let's say, and our own descriptions in order to be able, at the design phase to provide exactly what we deem as useful for the project. Our plan is to try to move to standards based, let's say, descriptions.
You don't know yet which ones. I mean, there's a few open source.
However, the descriptions we have already designed are very close to existing ones. So we just need to do the exercise of figuring out what we are missing from each case.
Okay. Thank you very much, Christos. Let's move on to the next project, the Myrtus project. Francesca Palumbo, please.
Hi, everyone. I'm Francesca Palumbo, the scientific coordinator of the Myrtus project. Myrtus stands for Multi-Layer 360 Degrees Dynamic Orchestration and Interoperable Design Environment for Compute Continuum System. The project just started. It started in January 2024, and the consortium is composed of 14 partners from 8 different countries that brings together highly different competencies and background, from low-level architectural specification up to software management strategies. Next slide, please. Our primary goal is to provide efficient computing continuum management, leveraging advanced technologies based on AI, such as federated learning and swarm intelligence. And to do that, we are building a complete ecosystem. Next slide, please. Indeed, we will define in the project a computing continuum infrastructure that I will show in a couple of slides, composed of heterogeneous resources. So heterogeneity is really at the base of the project. Next slide, please. This heterogeneity of resources is going to be orchestrated by Myrto, that is the AI-powered orchestration engine, and represent the core of the project. Next slide, please. And finally, to design to master such a complexity and to deploy efficiently such a complex infrastructure, we are also offering a design and programming environment that in our idea is meant to facilitate the uptake of our solution. Next slide, please. Everything is going to be tested within two really challenging scenarios. One is smart mobility, and the other one is virtual telerehabilitation, that are going to ensure that the projects will deliver really solution for effective and modern test case. In this presentation, I don't have many details related to the use case, but I did it on purpose because the project is technology driven and not use case driven. But if you have questions, yes, please feel free to ask me questions about them. Next slide, please. I will go through the different challenges that we tackle that are basically the foundations, the research question behind the solutions that we are trying to push. Next slide, please. The first challenge that we have in the project is to provide scalability and low latency while ensuring privacy matters. To do that, Myrtus aims to define a reference infrastructure where edge and fog devices converge with the cloud to form this continuum. And in order to address all the needs of complex and specifically dynamic systems. Next slide, please. At the edge, we are going to leverage and we are going to develop solutions mostly related to FPGA devices that will go hand in hand. Next slide, please. With different resources at the fog. At the fog, we have different type of capabilities. We have some smart bridges that really acts as simple bridge between edge and cloud, but also other more complex computing nodes that are going to act as micro data centers close to the edge. Next slide, please. On top of them, we will leverage on cloud resources to be able to provide strictly non-real-time computing tasks and a larger and to offer larger storing capabilities. Next slide, please. To achieve a flexibility in general and to overcome the current silo-like management solutions for this type of computing continuum of this type of infrastructures, we proposed the development of Myrto. Myrto is going to be a firmware which aims at pushing runtime adaptivity within a single layer and across layers. Indeed, we are aiming for 360 degrees of orchestration, bottom to top and top to bottom. Next slide, please. We are going to leverage resource monitoring and runtime orchestration to enable this high performance, low latency, and energy efficiency while ensuring privacy and trust and security as well. And in our idea, federated learning and swarm intelligence will play a major role in the orchestration in order to guarantee really the efficient load optimization, the load distribution, at the same time preserving the information that are at the edge, exploiting federated learning, for example. Next slide, please. As I said, to facilitate the development of this kind of system, you need also, in our opinion, a design and programming environment that will easy the developer lives. And so we are, one of our goals is to provide this design and programming environment for the Continuum. Next slide, please. In this programming environment, we will have many different tools which will cooperate together and will offer and have capability that goes from modeling the infrastructure to the programming the single nodes. And the idea is leveraging on standard and widely acknowledged technologies like Oasis Tosca, which will enhance the portability and operational management of distributed applications and services across the Continuum for their entire life cycles. We will also leverage MLIR for all the to be able to share information among low-level development tools. Next slide, please. This picture is trying to summarize the impact that we want to achieve at the end of the project. We are already in contacts with relevant communities and projects, and I want to highlight that at the moment we are in the first 6 months of the project, but we are trying to frame, for example, our solutions with respect to the reference of architecture that is under the definition of the EU Cloud-Edge-IoT initiative, in order to make sure that we are not diverging with respect to the solutions that the community has already pushed out there. And this basically concludes this short presentation about Myrtus.
Thank you very much, Francesca. Hyro Microdata Centers is in a few of these projects, and one of the projects that we're going to present, and I'm going to be very brief and probably be scrutinized by my consortium to have such a compact slide presentation. I have one slide, please. Yara, can you? Yeah. So the ACES project is a project that started 16 months ago. The vision that we're pursuing is the creation of autopoietic orchestration in a powerful edge cloud. So the ACES consortium believes that a powerful edge cloud, distributed infrastructure, is basically the ticket out of jail for Europe, out of the, let's say, large cloud service providers. So if we can create a powerful edge cloud, the first step from a device onto the web, and from there orchestrate, let's say, the distributed infrastructure and be able to run, for example, a hybrid or a multi-cloud environment, then basically there's a whole lot of room for, let's say, new cloud service providers at the edge. So in order to make that available, we believe that this powerful edge infrastructure that sits in different locations needs to be autopoietic. And autopoietic behavior is kind of like a very old term, where it basically means it keeps itself alive. So it's not only auto repair or self-repair or self-cleaning or self-organizing, but it stretches beyond that and also allows itself to expand to locations that are not being used yet. So it's really, let's say, a living system. Fundamental in our design is the orchestration, basically where the devices claim or offer workloads to the powerful edge, and that the powerful edge then self-organizes in order to make sure that we meet the SLAs and the SLOs of the devices. From the research that we did, at least the desk research that we did, is we saw that, let's say, beneath reinforcement learning, and reinforcement learning itself is not fast enough to handle the dynamics at a powerful edge. So whether you talk about interacting with cyber-physical systems or simple devices that don't need a real-time servicing, it's very difficult to create some AI or ML that is able to manage all that diverse type of workloads. swarm technologies offer a super fast response time. The only downside about swarm technologies is that it's not explainable, and it's very difficult to control because it's emergent intelligence, and we don't know where that intelligence is going to go. So in order to make it trustworthy, the ACES project envisions to use AI and ML to understand the swarm behavior, the swarm orchestration, and to control the settings of the agents in the swarm. So I think ACES is the first project, as far as I know, that tries to create explainable, trustworthy swarm behavior. What do we use for that? We do a few things. So we use some AI ML to understand the efficiency of the swarm on the distributed infrastructure. There's one thing. We characterize workloads in a knowledge graph that we then can analyze and understand the relationships between the various applications and the pods in applications. And the third thing that we do is we also allow the orchestrator to orchestrate pools of resources. So in the future of cloud and edge cloud, new technology is coming that is basically composability of infrastructure. So that allows you to combine pools of CPU, GPU, or FPGA cores with pools of memories and pools of storage. That technology is being launched slowly by some of the large OEMs, and the ACES project tries to anticipate that by developing an orchestrator that allows you to take that into consideration as well. We have one large use case because we found it already complex enough. So we are using a use case that is the intelligent energy grid. So it's a grid operator in Greece, where we are basically running a number of their applications from their platform on our infrastructure, and that requires the infrastructure to behave, let's say, in an autopoietic fashion. That is as much as I would like to and can share at the moment. We have a range of technologies that you see here in the high level architecture, and we will also be next week in the conference in Brussels. So there we can talk about it even more. Thank you very much. So those were all the projects. I think if I look at all the projects, what is interesting and what struck me now while the presentations were done is all the projects stretch across a continuum. So they try to bring together collectives of devices, systems, subsystems that are also heterogeneous, so have different capabilities, and tries to orchestrate them towards a kind of collective behavior, which is very different than the projects we saw in the previous webinar. So I find that fascinating. And then the first question I would like to address in the session right now is the AI that we are using in our solutions. How do we make that AI, let's say, flexible, lean, lightweight, but at the same time powerful? What kind of solutions are we pursuing this? Because before you know it, AI and ML, the tools that we use become so heavyweight that they have a huge cost impact and latency impact and various other impacts on our, let's say, solutions. Shall I go through the projects from the same order that we had? So maybe Sabri, could you comment on that? How do you keep your solutions lightweight, flexible, but at the same time allow them to continuously be trained?
I think I agree with you that that's one of the challenges. So of course, it's attractive to think, okay, I'm going to use AI to tackle or to solve a complex problem like orchestration of the computing continuum or optimal mapping of resources to the workload. But there are a lot of challenges, and in our project, we have a parallel development of, let's say, scheduling tools with use cases. And since AI is data hungry, it means that you would need to have infrastructure running, use cases running to have sufficient data to train with models. But we are just reaching at the mid of project the state where our use cases are basically becoming mature that can generate enough data for training. We have enough data for, let's say, high-performance computing system on premises, but that's just part of the continuum. But if you look at the whole spectrum from devices, let's say, at traffic intersection or drones at emergency response, for the whole spectrum, we didn't have, and we don't have, I think, sufficient data yet to train our model. So having data is a challenge. It's a question of chicken and eggs, basically.
Yeah.
You need data to train the model, and you need models to operate the infrastructure. So we hope to reach this point at the middle of project somewhere, and we are just close to it. So our use cases are starting to produce the data that we need.
And Sabri, if I understand correctly, you have kind of like an overarching model, and you have data that sits in different locations that describes the particularities of, let's say, the different locations on the continuum. That data needs to flow to the centralized model, be trained there, and then the inferencing can start. Am I correct?
Yeah, so that's our aim. So what we are in better position is to handle, let's say, resources within high-performance computing center, because traditionally we have a lot of data for such systems, historical data.
Good.
So another issue that you mentioned, and it's a challenge for everyone, I think, it's you need to make decision quickly, so overhead should be low to make it useful. If a scheduling decision or orchestration decision takes too long, prohibitively long, then I mean, if we add the execution time and decision time, at the end, maybe it's better just to run in any form because overhead is so high, so it's prohibitive to use. So we would need maybe it's a strong focus on various kinds of artificial neural networks with all their advantages and disadvantages. My vision for future would be maybe to look at other machine learning methods, not only artificial neural networks. So there are faster methods at internet time than artificial neural networks are.
Yeah, let me check with a few other projects. I remember there was one thing when I was talking to Intel, they told me, Fred, when you talk about intelligent machines, and for example, you have a 64 or 128 core CPU, the intelligence you need to do the orchestration or whatever it is should maximum take one core. If it takes more than one core, basically it's too much overhead, which was, I think, an interesting benchmark from an industry player, right? Francesca, I will come to you. I will jump the queue and go a little bit back and forth. Same question to you. So how do we keep the AI and the training lightweight? What kind of concepts is Myrtus looking at?
Yeah, in Myrtus, we are going to extensively leverage federated learning, for example. The idea is to use lightweight models at the edge, for example, on the FPGA accelerators that are really close to source. We are going to have there running AI models to predict energy consumptions based on the workloads. So to say whether we can fit within certain trade-off. And the idea is work very closely with the upper layer. So Myrto will stretch our cognitive engine. Will stretch across layer to allow us to make this federation of resources, to exploit federated learning, to ensure that there's a constant retraining at the edge and no data are exchanged, but just the models themselves. And we will exploit the different layers for different goals, basically. Of course, we expect to take better decision probably in the upper layer where you have let's say longer time frame to be analyzed because you have larger historical data and so on and so forth. So basically federated learning in our project is fundamental to do this. And we have already an infrastructure in mind for Myrto, the cognitive engine that will leverage on a distributed knowledge base that will make all the different resources aware of the status of the infrastructure. And the combination of these two technologies should fit in our case. This is the goal. We just started the technical work packages, so it is yet to be demonstrated that this will be sufficient or not.
But I think what I like about the Myrtus project, and I see it also in ML SysOps, and I will ask Christos in a minute about that, is this. So in let's say the past 5 to 10 years, we always looked at, okay, the cloud controls the fog and the fog controls the edge. And there's kind of like this hierarchy. And here we turn it around. Here we say the fog serves the edge in their autonomy, and the cloud serves the fog in their autonomy. And they just provide information on the right level for the decision making to take place there, right?
I would say that it's even more democratic, probably, in the sense that all the layers as its own autonomy, and you can reconfigure things within a layer. But then, if you need the service of another layer, Myrto will guarantee this in a seamless manner. This is the idea. So when I said that from top to bottom and bottom to top and vice versa, this is the idea that there's not one way only. With respect, you said in the past, solution were normally one way only, and indeed we are trying to remove this one-way direction. We are looking at the problem from a 360-degree approach, and with the idea that sharing these knowledges across layers and having these Myrto agents that are basically the same, but with these, let's say, target specific features will help a lot in achieving this seamless approach.
Yeah, Christos, in ML SysOps, you have a similar approach where you also have these different agents. How do you keep it lightweight and still very accurate and let's say close to real time? This operability across these different layers. How do you facilitate that?
We use this hierarchy to make sure that different concerns are addressed by different levels of the hierarchy. And the layers near the top, they take very high level decisions based on very high level information. And as we go to the individual nodes, we have more, let's say, concrete requirements from the ML model on the node, and the model results to very, very concrete actions to configure the system or to manage the applications. Now, beyond the hierarchy, which allows us to use simpler models and to keep models very close to the data they are going to be trained with, There are two additional key elements. One is continual learning. So, of course, we shouldn't have to retrain models from scratch when there is a drift. And at this point, we also have to be very effective in detecting drifts and in let's say, estimating the cost of a drift. So every time we detect a drift, there are two ways to go. One is to train the model immediately. The other is to postpone that till we find some slack on the system. So every time we detect a drift, we estimate whether running suboptimally will have more cost than retraining the model immediately, at the risk of using resources that are going to be useful to the applications at the same time.
Yeah, and that's when drift goes beyond a certain threshold, right?
Right.
Not any drift. Yeah.
And beyond a certain cost. The other thing we pursue is to use transfer learning. So there is an initial period when the models start being trained, where essentially decisions are going to be suboptimal. So we wouldn't like to start training a model from scratch on every individual node of the system. So what we're looking at is whether we can use pre-trained models potentially from slightly different nodes and be able to adapt them on new nodes on the system.
So in that sense, you become very flexible, because when new nodes join, let's say, the continuum, you can immediately, let's say, deploy a model on them, and they can slowly then ramp up in their performance in the whole infrastructure, right?
Exactly. Yes.
Yeah. Let me check also with Hyper AI, because there's a similar. Yakovos, please let me. Well, how do you think about this?
Well, making AI lightweight. I mean, this is a very, very long story, I would say, because I mean,
Don't make it too long.
No. I mean, this can be almost philosophical discussion, but I mean, there are two ways to go. Either you create a complex AI that can undertake quite complex tasks. So this is a complex AI, which is very tedious, a lot of data, large models, a lot of training workload, but is very accurate and is very, let's say, capable of handling different situations, is robust. Or you create smaller ones. So you create a hierarchy, right? So let's say the different layers of the hierarchy operate at different situations. So you don't have to run the whole thing and train the whole thing always. So you create mini batches of AI, let me put it this way, that are trained for different reasons and are active for different reasons. This is one way to go. Another way to go is, I mean, this is the how to say, the vertical, let's say, separation of AI, AI tasks. And another way to go is to go horizontal. So distribute it, decentralize it. So don't create silos, don't create central, let's say, approaches, central schemes, which may be more accurate, but much more tedious. So this is actually what we're trying to do in Hyper AI. We are trying to decentralize state estimation, create smart nodes of different life cycles. So create clusters, and then let's say delete them and then create again. So this is a live, let's say, thing that are also capable to train themselves locally. So using estimations for the entire, let's say, situation and train locally.
Yeah.
This is what we're trying to do, at least in Hyper AI.
So if you could conclude, basically, if we look at the various projects, and something we'd also try to do in ACES, then maybe in a slightly different way, is we try to horizontally and vertically create, let's say, distributed AI, right? So instead of to make one big model, we create distributed AI. And the challenge about that then is, how do you define what one AI does and the other AI does, and how do you make it so ontologies, semantics, definitions then come into play. And I think that's, of course, needed also if we talk about, the data economy in Europe, and we want a lot of players to become part of this. That's the way forward then, right? Okay, so let me go to another question that is, and that basically, follows up with this question is, what do we need to do in the future? So if conceptually we were right, and so we talk about distributed AI horizontally and vertically, we talk about semantics, ontologies to make it work, to create collaborative behavior between all these various models and devices and subsystems. The next wave of cloud calls, what should we ask for to be developed in order to help us to make that next move? And I go to Panagiotis first from Imperium, because I haven't asked you yet about commenting. Please, if you could.
Yes, thank you. So I think the next call should be about I'm making this applicable to domains. I mean, we have our use cases. All projects have the use cases. We do our stuff. We integrate with companies. But from our experience these last few years, we see that companies they are sometimes surprised by the things that we develop. So they want to integrate, to use this AI, this edge, but they don't know how. So and the use cases, we do part of this process of introducing them to these technologies. But I think there's a lot of way to go in order for them to understand and use them. So though we have the use cases, I think we have to do them in a more larger scale. I mean, to find ways, to actually use them, the technologies, because we develop a lot of technologies, but companies and industries, they have the cloud, and so it's cloud, everything in the cloud. So we finish there. So we have to find ways and means through the projects to actually use them and incorporate them in their business cycle. Let's say, I don't know how the business term is, but something like that. Thank you.
Yeah, I understand. So basically, what you're saying is, first we had technology calls, and now we should focus on the other industry verticals, and they should launch calls to say, bring all those technologies to us in agriculture or into manufacturing or into whatever, transportation or logistics, and bring the whole stack and help us implement it and experiment and push the integration further, right? That's basically what you're saying.
Yes. And in practice, we see industry moving in parallel. Let's say they have products that are edge nodes. So many companies, they develop stuff that they do processing, but they don't call them edge nodes. They call them EOT nodes, but they're not EOT nodes. They are edge nodes. So they move in parallel, but we also moving in parallel. So we have to, connect at some point that what you have is not just a sensor. It's a computing device running in the edge. So let's connect it. I think this is very important.
Francesca, what do you think is needed for the future calls?
I think we need a little bit to break the walls. That goes in the direction that the other speaker was just saying. There are a lot of initiatives, and I think that having a reference architecture will help a lot, but this needs to become a standard somehow, not just a standard de facto, because many initiatives are there, many tools are in the process to be developed, but for example, we are looking at ways to model things at the cloud, at the edge, and at the fog. And it's difficult to identify a format that can be really used across layers. And this is an issue. I mean, we are looking at the Oasis Tosca, for example, but as far as we know, for example, at the industrial level, that it's still not widely used, so we are still reflecting whether this is the good direction or not. I think a push for standardization, a push for languages across layers would help a lot in establishing concrete solution that can goes then at high TRL level. Because if you want to go to the market, you cannot end up with a TRL 5. TRL 5 was the expected TRL in our call, for example. I think we need to push a little bit things further, and we can do that if we can break the walls between the research projects and the industry with also standardization initiatives.
I think I fully agree with that one, because if you want to work with the AWS cloud or any other cloud, you need to go through various training sessions to understand how that cloud works and how you can have maximum benefits from it. And if we create kind of like this landscape of various technologies, we need to integrate them. We need to have also bodies that say, okay, this is the whole package. Come and do your first degree in education and to understand the technologies and how to apply it.
Yeah.
We need to mimic what the large players do, but we need to mimic it as a group, right? I fully agree. I go to Sabri. What do you think is needed in the future calls for cognitive cloud?
Yes, so I think it's an excellent question. So I think that for the foreseeable future, computing continuum will remain important. So I think most of modern applications will run in something that we can call computing continuum. So there is no doubt for that it will remain important. And what I want to express is that the first wave of projects, they are mostly 3 years project with, I would say, modest funding compared to the multi-billion funding of big techs, let's say, technology companies. We are actually small, but we are somewhere between fundamental research combined with, let's say, use cases when we try to apply it. So we need to consider in future calls recent advancement in fundamental, let's say, AI research. And we need also to take into consideration this prototypical development in the first wave of computing continuum projects. After 3 years, we will have some prototypes. They will not be mature, but they can show, let's say, what can lead to the success. And as they say, usually success overnight, it usually takes 10 years. We have seen that it took 10 years until grid computing was, let's say, successfully commercialized as a cloud computing. And we know how many projects we had between 95 and, let's say, end of somewhere 2010, or when cloud computing, became successful. So I expect 10 years, let's say, again, research and development to have commercial success in this domain.
With the only difference, Sabri, that the cloud powerhouses are now there, right? They're only
different resources. Yeah,
exactly. They're only becoming bigger. So if we want to become, let's say, more, let's say, digital sovereign in Europe, we need to be faster. We cannot wait 10 years, right? So I understand that our projects take 3 years, but I think 6 years we should see the first successes already of European industry and embracing European developed cloud solutions, right?
Yeah, definitely it's true. So I think entrepreneurship is still something that we need to pay more attention in Europe. So we usually are good in generating prototypes, new concepts and ideas. Maybe we are behind other continents like Americas and Asia when it comes to entrepreneurship and ambition, I would say. So even though startups are sold too early, I would say, to big techs. So we need maybe entrepreneurs with ambition. Let's say, okay, I don't want to sell my startup for a few millions. I want to become a trillion company, let's say, and I want to work in this for my next 30 years. But unfortunately, even successful startups from previous European Union projects that I participated, in my opinion, they were sold too early, and it was an exit strategy. It was a success in some sense, but nothing that you can compete in future then with other continents.
Yeah, I fully agree. Thank you very much, Sabri. That was very insightful. I will go to Christos. What do you think is needed for future calls?
I tend to agree with the other projects. So we need to move a bit towards maturity. We need, for example, to consider things such as usability, programmability of those systems. It shouldn't be, really painful to the end user to use our system. It should be as seamless as using a cloud system which is out there commercial. We also have to focus on specific domains, both as applications but also as tests of the trade-off between generality and specialization. So we provide some solutions. We try to be generic. However, there's always the question, how realistic is this? What is the trade-off between generality and performance or applicability?
So which domains would you focus on then? Which domains would you promote?
Smart industry, health, smart cities, smart agriculture. Those are domains where
top four.
We have already identified them, and smart vehicles, and they are out there. Still, however, we will move towards maturity. At the same time, we will probably have to revisit the basics, because technology, both in terms of AI and in terms of hardware supporting AI, evolves really fast. So today is a totally different world compared to when proposals for those projects were being drafted. We have very different technologies, basic technologies in terms of AI. At the same time, we have vendors providing AI optimized hardware. So a model that was expensive in the past probably is going to be feasible in the near future to use. So we should not forget the basics.
Yeah, and I think one of the bottlenecks there is, you're right, hardware is moving. Okay, we're developing European chips, but European chips is not like a full hardware solution, right? And the big solution providers are developing their own platforms. NVIDIA is going to come with a turnkey solution, not only hardware, but AI platform, data management. The whole stack will be there. They will set up their own AI super data centers, let's say. So and the other cloud providers are going to do the same. But so you're right. It's not only about building that software stack, but building that software stack with new technologies that are coming. And then how are we going to solve? Who's going to develop the platforms, right? The hardware platforms for it in Europe. So yeah, that's a very good point. Thank you. Who else did I miss? Someone I missed. Panos, did I miss you in asking you about the future?
Panos, yeah, I answered in the beginning. If you asked about, thank you.
Yeah. So I think that we had everybody, right?
Well, I agree with the ones that let's say already commented. So yeah, my opinion is fully aligned to that. I mean, for me, just a remark. I know that everybody agrees, but just to also use a keyword that I like. Maturity also means standardization. So aside from let's say use cases, applications, we need to standardize things, because I mean, in terms of semantics, ontology, representations, architectures, all of this stuff.
Yeah. And I think also what is an opportunity also, I think, if we standardize, then let's make sure that those standardized are becoming also from a legislation point of view enforced, right? Because otherwise it's very difficult to compete with non-European, let's say, technology providers that don't want to comply with those standards, and that have tons of, let's say, data to train their AI, and then they bring their AI to Europe, and then we go, okay, but How can we ever compete with those? Yeah. Okay. So if there's one conclusion that you could draw from this webinar, which conclusion would you draw? And I do ladies first. I go first to Francesca. What conclusion would you draw from this webinar? What is something you will take home? And you're home already.
To be honest, probably we should go a little bit more in depth about the technologies to draw, let's say, a technological conclusion, to learn what is better, what could be applied, and so on and so forth. One conclusion that I will bring home is the fact that all these projects that presented today are struggling with common problems: semantics, ontology, which models to use, which standards to adopt. And I think that one of the takeaway that I will bring to the Myrtus next meeting is to try to share a little bit more with the community, to try to organize more roundtable about these common problems, because most of these projects are about to define their own requirements, to define the interfaces and the models, and we are struggling on very similar projects, at least those projects that are not using the top to bottom approach. So my conclusion is that more synergies are needed to solve these hot problems. That it's not will I use AI or not, but what type of models are most suitable in one scenario or another? What type of standards can I use? Especially in terms of languages and ontologies that I've heard in all the presentation as one of the barrier at the moment.
Yeah, I think it's a great idea to basically bring, because I think we have all the players in the room to discuss this, to set up a group discussion specifically on specific technology. So I think Myrtus will probably take the lead in getting us together, I guess. Thank you very much, Francesca. That's great. Christos, what is the thing that you take home?
So I really like the fact that all projects discussed today share common things. However, at the same time, they follow different approaches, which is really healthy in terms of trying to explore different paths. I also I would agree that we need more communication and more sharing of technologies, data, models, standards, you name it, to make sure that all the efforts from different projects at the end of the day go towards a specific direction.
Yeah, perfect. Thank you very much. Jacobos, what do you think take home?
Yeah, for me, it's as Christos mentioned. So, of course, it's interesting that we try to tackle common problems. So, exchanging, let's say, opinions or different discussing from different points of view also helps, because widening creates, you can create the larger picture and see some things that you may have not seen or realized before. The way to move forward, I mean, if you consider us as a community of people working on common problems, is openness. Openness means, discussing, exchanging ideas. I don't know, maybe snippets or let's say tools, or create initiatives towards this direction, because we are tackling common problems. And I think that, I'm sure that some of the projects are strong on one aspect, other projects are stronger on another aspect. So we can merge eventually towards the fighting the same goal. And merging means also standardization, as I mentioned before. So
yeah, I think because everybody's developing a piece of the technology, piece of the puzzle, and we're not part of one organization, that also creates some, let's say, barriers and thresholds, right? If you work for a large cloud service provider, you have tons of teams and they all need to integrate There's no discussion like, oh, it's mine or it's yours, or who's going to make money out of this. So that is a challenge in Europe, right? And that's basically something we need to overcome. And I think as a single solution provider, you're not going to make money if you don't integrate with somebody else. AWS is not going to buy your technology. They're just going to copy it. So thank you very much. Panagiotis, what do you think? What are you taking home?
Yeah, something along the same lines, I suppose, as the previous speakers, since we are developing many components that have similar functionality, we need to identify what these components are. For example, we everyone use Kubernetes, or most of them we use Kubernetes, so this is fixed. But we have to move a little higher than that. Kubernetes and what other we all develop. So we have to identify things that we all develop similar, and then say, okay, we will use something like that, and then move forward to other developments, to other aspects that are more difficult or more challenging to address. So yeah, that's my 2 cents.
Thank you very much. So yeah, Kubernetes. Yeah, and it's part of the standardization, right? What are the tools that we are basically committing to collectively, and then push further, right? I think that would be also create a lot of synergy. Sabri, you're the last one, sorry, in the row. What are you taking home from this webinar?
Yeah, I think we need more of the same, I would say. So we need more cross-project communication. And as I think Christos mentioned, and there has been also some communication between the sites and ACES, maybe use the infrastructure of IP conference for next, let's say, interaction.
Oh, that's interesting. Yeah.
So I'm fully support this initiative that, let's meet at High Peak. We can call it a workshop of Computing Continuum, European Continuum projects.
Yeah.
And let's use the meeting in Barcelona in January. After approximately 2 years, we will have a clear idea of where we are and where we are heading.
Yeah.
So I think it would be very useful if we meet there in some form of workshop. And another idea is that if we feel confident at the workshop, we could maybe consolidate knowledge created in this project in some kind of edited book, let's say, that will remain for the project. So lessons learned on the long term.
Thank you. I think from Mirtis, we definitely will reach out sooner. We will not wait until High Peak to discuss basically technology choices and standards. I think it's also a very good idea to maybe pass it as a standard element in a High Peak meeting where European projects come together and basically start doing sharing sessions and having more in-depth discussions, which is a different format than just presenting your project, right? We should go there as a group of projects and say, hey, let's sit together and discuss more in depth. So I will see if through High Peak we can do that. And Luca, we are going to High Peak,
no,
right?
Yeah, we are. Sorry, I need to close the circle. I don't know if Fred and Sabri have met before, but we are planning a joint workshop in Barcelona in late January 2025. And these are the forms we discussed the other day.
Perfect.
So, I mean, we have a deadline, which is the 1st of July. And then I think once we have the concept, which we as ACES will develop and propose to Sabri, who will then enrich it, and then we can take the chance to use this as a basis for a wider dissemination, and maybe other consortia and other actors will want to join us in Barcelona.
Yeah, we will reach out to the other projects as well in this webinar and see what we can do more together. All right. So I leave the floor to, I think, Luca?
No, Alessandro.
No? Also,
Alessandro is replacing Francesco and will talk about Tema and glaciation.
Okay. Thank you very much. Alessandro, over to you.
Hi everyone. Thank you, Fred. Thank you, Luca. I think I share the screen, right?
Yep.
Or no, we have it. Yeah, no, that's
Okay.
even better. Yeah, perfect. Thank you so much. So, hi everyone. Well, I'm not a doctor and I'm not Francesco, as you just found out. I'm Alessandro Paceroni. I work at the Lisbon Council in the team that works on Horizon projects under Francesco, that is the senior director. And my personal background is more on public sector innovation and digital governance. So I will present Thema and glaciation, and perhaps I will just draw a couple of lines more on a policy and governance level. So what is the motivation that brought us to Thema? We can move to the next slide. Is sudden. Okay, wait. Can I? Sorry, yeah, but oh well, there's a different slide. Anyways, well, the objectives, but I will still speak about the motivation first. So the motivation is that sadly we all know that climate change has had a big impact on our lives. This impact is set to grow more and more, both in terms of biodiversity loss, resources, in terms of houses and so on, and unfortunately also lives. This is happening across Europe, across the world, and clearly does not see boundaries in terms of countries, regions, and so on, political boundaries. And it also does not, I mean, sees an increase in frequency and in scale, which makes this whole picture even worse. Luckily, on the positive side, we have new technologies that have been developing quite fast. And these technologies, such as drones, AI, extended reality, so both augmented and virtual reality, cloud, edge computing, and so on, have been improving and can consistently help us coping with this kind of scenarios. They can do so, broadly speaking, by enabling us to harmonize more and more data coming in at a faster speed from different and heterogeneous sources. They can help us analyze this data faster and with more accuracy, and overall orchestrating all this also in terms of resources needed for computation and so on, in a way that is more resilient and that optimizes the use of energy. And here I'm sure you already see the tight link with the cloud-to-edge continuum. So overall, Thema seeks to improve natural disaster management, to improve and accelerate the data analytics. This is what I was just describing. And eventually, this is useful to the end user by enhancing the phenomenon modeling, the quality, so accuracy, rapidity, and so on, the predictions, and then also the visualization. We can move to the next slide. So overall, Thema as a tool is an AI-enabled natural disaster management platform that offers precise semantic 3D area mapping and has an interactive, intuitive, and accessible visualization. What does this mean besides the bullet point? We get data from heterogeneous sources, going from satellites to IoT sensors, drones, and so on. This data is harmonized, so not integrated, but harmonized using a context broker. And through this is then fed into the analytics platform, which does what you see more in this slide. So which helps in terms of the phenomenon modeling and the situational awareness. We can move to the next slide. This is obviously using the edge to cloud continuum, as I mentioned before, and it does so in the sense that the whole platform spans from the cloud for mostly computing to the edge for faster communication. The impact of TEMA. Why? To improve the emergency response preparedness. How to improve the communication, the quality of communication between the different solutions and the quality of tools. And this is especially relevant in the long-term strategy, I would say, for the cross-border services that are enhanced in this with this solution. And the how this is done and what is done exactly. It's an harmonization of extreme data for phenomenon modeling and decision support. And we can end with a little bit of look at the practice, mostly related with the edge to cloud continuum. The solution harmonizes seamless sharing and use of data coming from heterogeneous sources that can be in this way analyzed in real time or quasi-real time. This is possible mainly because of the edge to cloud continuum that enables the computation and storing in an optimized manner. I think relevant to the discussion from what I've heard, not only today, but also in other debates, is the fact that in this case, the edge is considered the control room, the mobile control rooms that are used by emergency response teams. So drones, for example, are not the edge in this case, but is rather a mini server that is used, for example, within the control rooms of the Red Cross. And this concludes the presentation of TEMA. So we can move to glaciation. Yep. So glaciation is another Horizon project, and the Lisbon Council is part of it. We can go to the next slide. So motivation. In this case, we have the slide regarding glaciation. Citizens produce a lot of data. Basically, we are the citizens. We produce a lot of data. We produce them, and we use them often at the edge. So on our mobile phones, for example. And in this sense, privacy it's fundamental. It's usually very highly valued by people, and this, however, creates a situation where data is not necessarily stored at the edge, and in this sense could create a trade-off between the privacy and what can you actually do in terms of computation with data. Businesses at the same time produce also a lot of data. They also collect a lot of data, mainly and mostly from citizens. And they have to store them, transfer and analyze them across the network, which sometimes, for example, in a factory, it's local, but it can also run on the cloud. In this case, privacy, it's important from an intellectual property perspective, but also in the sense that businesses are the ones that are storing citizens' data, and that are then trusted with the data and have to be compliant with certain regulations in this sense. The public administration does pretty much the same as businesses in this sense, so they collect a lot of data. They use them for various services, which are, if you allow me, even more fundamental than business services sometimes, for the aspects of our lives that they touch upon. They also still have to comply with regulations. They are also basically trusted with our personal data. And I would say that both public administrations and businesses have to keep in mind their climate impact, but certainly when we talk about public administrations, as they are, our democracies and governments, they even are more accountable towards citizens in this sense. So moving on to the next slide, we draw a line between these different stakeholders and different perspectives. And we see that the objective of glaciation is, given the resource consumption and the privacy, creating a solution that can optimize the energy efficiency and the operational performance of data movements across the whole cloud-to-edge continuum. So in this sense, the idea is that we want to have the best computational power possible for our services, for what we do with our data. At the same time, we want to ensure privacy across the whole data lifecycle. And there are, depending on the level of the architecture at which we are, there are different pros and cons in terms of computational capacity and privacy. So having an engine, having a platform solution like glaciation behind it allows us to optimize this movement of data across the different levels, so that according to a set of so to speak, predetermined parameters that can be dynamically adapted with AI, enables us to have the best trade-off given the parameters between privacy and computational power. We can move to the next slide. So this is the architecture which underlies the concept that I just explained. There is a metadata service that runs across the continuum. This is needed to enable this optimization of the data movements that I was mentioning, the data storage service, obviously, and the processing, and a series of other more detailed service that I won't go into detail on in this presentation. We can go to the next one. So the outcomes, which I pretty much already summarized, are energy efficient data management, privacy preserving data sharing. These are the main two, I would argue. There is a big a very important outcome in terms of the validation metrics that is developed within the project, and data governance, a data governance mechanism. All this with an AI-powered engine that enables the optimization of the algorithms that run this optimization of the data movements. And we can go to the final slide. That is just an overview of the impact, which going from a more conceptual level supports the twin transition, so both green and digital, but also going a bit more into detail, enables regulatory and privacy compliance, basically attaching a set of parameters that comply with the regulation and policy to the data. One can ensure that the platform's glaciation runs according to these parameters. This ends the presentation of glaciation. Thank you so much for your attention.
Thank you very much, Alessandro. Maybe, sorry, we're not going to draw like general conclusions that we already did before your presentations about the various projects and what we need to do in the future. But maybe something I would like to highlight in all our interests is, so we talked about standards, semantics, and connecting these various, let's say, levels horizontally and vertically. The reason why we are also in the glaciation project, one of the reasons why I initiated the glaciation project idea, let's say, and Dell took a large responsibility in writing the proposal, is this. It's very difficult to connect a distributed environment, whether it's hardware, databases, data spaces, individuals, or whatever it is, So knowledge graphs allow you to map that, right? The complexity of this is how to fill the knowledge graphs. Well, with the recent strong developments of large language models, actually, tools become available to kind of do a first setup of filling a knowledge graph with the right, let's say, data, and then later curate it as you start implementing that knowledge graph. So the combination of knowledge graphs and large language models, I think for complex infrastructures that we're looking at, whether it's data sharing, data modeling, workload placement, whatever it is, the combination of knowledge graphs and large language models is something that we definitely should embrace. And what you see also is the large cloud providers are investing heavily in both of these two technologies. And I think for the same reason, right? It brings together distributed knowledge and allows you to search it in a much more meaningful way. And yeah, so that is something I would like to point out. I think that's it for today. We're already over time, 6 minutes. Am I correct, Luca? We're closing down, right? Luca already closed down, I think. Okay, then I would like to thank you all for participating in this webinar. I hope to see you soon in one of the one-to-one meetings or group meetings where we can discuss technology further. I wish you all good luck with the projects and hope to see you either in Brussels, High Peak, or on a future one-on-one meeting. Reach out to each other if you want to discuss more. Thank you very much again. Have a nice week.
Thank you.
And
Thank
talk to you soon.
Thank you.
Bye-bye.
Thank you.
Thank you very much.
Thank you all.
Bye.
Thank you all.
Bye.